Alrighty. Hello, everyone. This is Dr. Jordan coming to you by remote. Okay, so this is number one. Again, we're on minute 11 at the eighth grade level. Again, minute math at the eighth grade level, minute 11. I read, order the integers -10, -25, 25, 10, and -50 from least to greatest. Again, order the integers of -10, -25, 25, 10, and -50 from least to greatest. Well, I would go over a couple of things with my students because I'm very big on vocabulary. I would ask them about integers. Okay, even though we don't need to know integers to solve this problem, we kind of do in a sort of sense as where they are placed on the number line. So I said, what is an integer? Okay, and many students, some of the students will know, some of the students might not know, but even if they don't know, or if one of them do know, we'll have them to share that out. But if they don't know, then I, as a teacher, would tell them that an integer is a number, a whole number on a number line, and its opposite, and as well as including zero, because zero is an integer as well. Okay, so, and also on a number line on the left hand side, okay, so let's say we have the number line and the left side of zero. Oops. These numbers here, the further away from the zero that you are, the smaller the number. So even though, let's say if I had -2, and then I said that this was negative, say 6, -2 is larger than -6, even though 6 is a greater number by itself, but -6 because it's the furthest away from the zero. So I will do that. Okay, so with that being said, which number here would be furthest away from zero? Since we would start with our negatives, it would be -50, so -50. Then we got -25, -10, 10, and 25. So here, these are the numbers, the integers, which are whole numbers, including the zero from least to greatest. Okay, next one. Here we have 9 to the fifth power divided by 9 to the third power. Again, we have 9 to the fifth power divided by 9 to the third power. Where here the base numbers are the same. Okay, when we're going to divide, we're going to keep the base number, which is 9. And then when you're dealing with exponents and you're dividing and by the same base number, you just subtract. So 5 minus 3 would be 9 to the second power. And 9 to the second power is the same as 9 times 9, which equals 81. So here you have your base number, which is 9. And that means multiplying 9 times itself. It doesn't mean 9 times 2. It means 9 times 9. Okay, here, what is the area of the rectangle? What is the area of the rectangle? Many students might just say 150 because they know area actually means how many square units could fit in here in this particular space. Okay, and I would keep going on until I had 10 along this side and 15 along this side. And this takes forever. And I always start off like this to show them how long it might take. We have go forever and ever. So 15 times 10 means there'll be 150 what though in here? 150 square inches. Again, so it'll be 150. Don't forget the unit of measurement and don't forget your square. So again, 150 square inches. Okay, number 4. Here we have -2 times -3. Well, students, we will be working on this as well. We have been working on this. A negative times a negative yields a positive, and 2 times 3 is 6, so therefore it would be a positive 6. Here we have -9 and parentheses 4 plus 2 plus 3. Again, we have -9 and parentheses 4 plus 2 plus 3. And I will ask the students, whenever you have a number on the outside of a parenthesis, what does that tell you? Just reminding them, going, each time that we do this or, periodically. So the first thing they'll do, and please excuse my dear Aunt Sally, because again, we have the parentheses, we have the negative sign, we have the addition. We know to do what's inside parentheses first. Please excuse my dear Aunt Sally. So 4 plus 3 is 7, plus 2 more is 9, or 4 plus 2 is 6, and 6 plus 3 is 9. And then 9 times 9 is 81, but we have a negative, so it would be a negative 81. As a multiplying when the integers are, when the integers have different signs, then it would be a negative. Okay, the next one, -2 plus -3. Again, -2 plus -3 would be, well, we're adding integers, so the signs are the same. So we're going to keep the sign, which is a negative, and just add the numbers. 2 plus 3 is 5. Okay, give me a moment. So we go up here. Okay, let's make sure, get that 5 looking right. Okay, next one. 48 over 200 is what percent? Again, we have 48 over 200 is what percent? Well, the kiddos have been taught, or should know, that percent means out of 100. Again, some number out of 100. So here now we've got these two fractions equivalent to one another. So 200 divided by what will give me 100? I know that would be 2. Oops. And whatever you do for the denominator, and you must do for the numerator in order for this fraction to equal that fraction. 48 divided by 2 is 24. So again, the percent here would be 24%. Okay, here we're going to use greater than, less than, or equal to complete questions 8 through 10. And I always tell the students we're reading from left to right. So 3 is, what is it? Is it greater than -6, or is it equal to 6, or less than? Well, we know that here on the number line, the numbers to the left are less than the numbers to the right of 0. So therefore, this number here would be to the right of it. To the left. So we know it's smaller. Okay, even though the students would think that, oh, it's greater because 6 is greater than 3. Yes, that is true, but not -6. So again, 3 is greater than -6, or we would go read it backwards. -6 is less than 3. Okay, the students know the open mouth always points to the larger number, and the pointer always points to the smaller number. Here we go. The next one, -5 is blank to -3. -5 is blank. It's furthest away from the 0, so it would be less than, and the pointer is pointing at the smaller number. 0 is greater than -8. Same thing as relates to the number line. Okay.